All right, everyone, get ready for blast off because today
Oh, yeah.
we're diving deep into NASA's Blue Ghost mission to the moon.
To the moon.
I'm already super excited.
Yeah, me too. This is a big one.
Just thinking about it.
It's definitely a mission with a ton of potential.
Right.
I mean, we're not just talking about like another moon landing.
Yeah.
This is about testing technology that could like totally change how we explore space.
Yeah, think of Firefly Aerospace's Blue Ghost lander.
Yeah.
Like a lunar laboratory
That's a good way to think about it.
touching down near Mons Trail
Mons Latrey.
on March 2nd, 2025,
It's just about a month away.
with a whole array of NASA-developed instruments.
Yeah.
And we're kind of following along with this great article
Yeah.
from just a few days ago.
That's a good one.
Firefly's Blue Ghost nears lunar touchdown with 10 game-changing NASA instruments.
Zeb.
But what are these so-called game changers?
Right.
And what secrets of the moon are they going to unlock for us?
Well, for starters, let's go deep, like literally
Indeed.
beneath the lunar surface.
Okay.
We've got Lister on board.
Lister?
Yeah, the lunar instrumentation for subsurface thermal exploration with rapidity.
Okay.
This instrument is really going to help us understand the moon's internal heat flow.
So it's more than just, checking the moon's temperature, right?
Yeah.
What's so special about Lister's approach?
Well, think of it like this.
Sick.
Imagine sticking a thermometer 10 feet deep into the lunar soil.
Okay.
That's exactly what Lister's heat flow needle is going to do.
Wow.
It's not about a single reading. It's about mapping how the temperature changes at different depths.
Okay, so what can we learn from that?
We can learn a lot, actually. The way heat moves through the moon's layers
Okay.
can tell us about its composition, how it formed billions of years ago, and even reveal hidden geological features.
Yeah.
Some scientists think it might even point us to areas where volcanic activity once occurred,
Whoa.
long before humans ever walked the Earth.
Volcanoes on the moon, that's something I'd love to see.
Right.
But shifting gears a little bit, let's talk about a less dramatic,
Sure.
but equally important challenge.
Huh.
Lunar dust.
Yeah.
I know it's a big headache for missions,
The big headache.
but why exactly is it such a problem?
Well, lunar dust, or regolith, is incredibly fine and abrasive.
Okay.
Think of it like microscopic shards of glass.
Oh, wow.
It gets everywhere, clinging to surfaces,
Oh,
slogging mechanisms,
Yeah.
and even potentially posing a health hazard to astronauts.
Right.
So
Yeah.
Blue Ghost is testing two really innovative solutions,
Okay.
RAC and EDS.
Let's start with RAC.
All right.
Is it like a lunar dust buster?
Not quite.
Yeah.
RAC, or regolith adherence characterization,
Okay.
is more about observation.
All right.
It's got a set of sample plates
Okay.
made of different materials
Uh-huh.
that'll be exposed to the lunar environment.
Got it.
By seeing how dust clings to each.
Hmm.
Scientists can figure out which materials are best for future spacecraft, habitats, even spacesuits.
Oh, wow.
Think of it like...
So it's like finding the perfect non-stick coating for the moon.
Exactly.
Okay.
Now, EDS, the electrodynamic dust shield, is where things get really futuristic.
Okay.
It's basically an electric force field for dust mitigation.
An electric force field? Seriously?
Seriously.
Oh.
Imagine a grid of electrodes
Oh.
creating an electric field that repels dust particles,
Okay.
keeping surfaces clean.
So no more pesky moon dust bunnies clinging to everything.
No more pesky moon dust bunny.
Okay, that's just cool.
Yeah.
But wouldn't a force field like that mess with sensitive electronics?
That's a really smart question, and it's something the engineers have thought about very carefully.
Okay.
The electric fields EDS creates
Mm-hmm.
are strong enough to repel dust, but weak enough not to interfere with nearby electronics.
Wow.
It's all about finding that sweet spot.
So it's like a delicate dance
Yeah.
between repelling dust and keeping everything working.
It is.
Now we've talked about the moon's surface and its pesky dust.
Yeah.
But what about the dangers lurking beyond?
Ah, you're talking about space weather.
Space weather.
And we've got just the instrument to monitor that
Oh, right.
LEXI,
Yeah, like
the Lunar Environment Heliospheric X-ray imager.
Okay, so is LEXI like a space weather station on the moon?
You could say that
That-
the Earth's magnetic field, or magnetosphere,
Okay.
protects us from a lot of harmful radiation from the sun.
Mm-hmm.
LEXI is going to capture the first ever global images of this magnetosphere from the lunar surface.
So why is that view from the moon so important?
Because it gives us a totally different perspective on how the sun's energy or solar wind interacts with our planet's protective shield.
Yeah.
It's like having a ringside seat to a cosmic boxing match.
I like that.
Except the punches are radiation, and the prize is understanding space weather better.
Got it.
This data will help us predict and prepare for solar storms that could disrupt satellites, power grids, and even endanger astronauts.
Protecting ourselves from cosmic punches. I like the sound of that.
It's important.
But let's switch gears again.
Okay.
What if we could use our phone's GPS on the moon? Is that even possible?
It might be.
Really?
That's what the Lugiri experiment is all about.
Lugiri?
Testing the feasibility of using Earth-based GPS for navigation on the moon.
Wait, hold on.
Okay.
GPS satellites orbit Earth.
Right.
How could their signals reach the moon?
It's about signal strength and receiver sensitivity.
Okay.
While GPS signals were designed for Earth, they actually spread out in all directions.
Okay.
Some reach the moon, but they're faint.
Okay.
Lugiri is designed to pick up those weak signals and account for that vast distance, which could be a game changer for lunar exploration.
Imagine that using the same tech that gets us to our favorite coffee shop to navigate across the moon.
I know, right?
That's wild.
It's pretty amazing.
But as we venture further into space, radiation becomes an even bigger threat.
For sure.
Is Blue Ghost testing any solutions for that?
It is.
Okay.
Meet RADPC.
RADPC.
The radiation-tolerant computer.
Okay.
This isn't your average laptop.
Right.
It's designed to withstand the barrage of high-energy particles that bombard everything in space.
So what's so special about RADPC's design?
Think of it like this.
Okay.
A regular computer chip is like a delicate house of cards.
Okay.
Easily disrupted by a stray radiation particle. RADPC is built like a fortress.
Okay.
With radiation-resistant materials and redundant systems.
So even if one part gets hit, the others can keep the computer running.
Exactly.
That's incredible.
It's constantly monitoring itself for errors and correcting them on the fly.
So it's like a self-healing computer for the harsh realities of space.
You got it.
Now let's shift focus to the moment of truth.
Yeah.
The landing itself.
Relax.
What kind of view are we going to get?
We're going to see something truly spectacular.
Okay.
Thanks to CLPS.
CLPS?
The stereo camera for lunar plume surface studies.
Oh.
Imagine high-resolution 3D images of the Blue Ghost lander's exhaust plume as it touches down on the lunar surface.
3D images of a rocket landing on the moon.
You got it.
Sign me up.
It's going to be amazing.
But CLPSS isn't just about the spectacle, right? Understanding how that plume interacts with the surface, the dust it kicks up, the way it affects the lunar soil,
is important.
That's crucial as we plan to land larger and heavier spacecraft in the future.
Exactly.
It's like creating a blueprint for safer and more efficient landings as we ramp up our presence on the moon.
That's the plan.
Now, from the drama of the landing.
The drama.
Let's turn to something a little more,
well,
domestic.
Domestic on the moon?
You got my attention.
Well, we're essentially sending a vacuum cleaner to the moon.
Whoa, okay.
It's called LPV.
LPV.
The Lunar PlanetVac.
Okay.
But its purpose is far from mundane.
Intriguing.
Yeah.
So what's on LPV's cleaning list?
It's all about collecting samples of lunar regolith.
That precious lunar soil. And it's not just sucking up anything it finds.
Okay.
LPV separates the larger particles from the fine dust, giving us a more detailed look at the makeup of the moon's surface.
Why is that separation so important? I mean, it's just dirt, right?
Not at all.
Okay.
Different sizes and types of regolith tell different stories about the moon's history and formation.
Oh, okay.
This data is critical for understanding the moon's geology, identifying potential resources for future missions, and even figuring out the challenges of building a lunar base someday.
So it's like sifting for clues to the moon's past and its potential future.
Exactly.
But we're not done probing the moon's secrets yet, right? We're also sending LMS.
LNS.
The Lunar Magnetotelluric Sounder.
That's a mouthful.
This instrument is going to help us map the moon's interior without ever digging a single hole.
Is that right?
Map the moon's interior with no digging. Sounds like magic.
It's more like clever science.
Yeah. LMS utilizes the concept of magnetotellurics, measuring natural electric and magnetic fields to infer what lies beneath the surface.
Okay.
Different materials conduct electricity differently. So by analyzing these readings, we can create a 3D map of the moon's interior structure from its crust to its core.
Wow, that's incredible. We're essentially getting an X-ray vision of the moon.
We are.
And that X-ray will help us understand how the moon formed, how its interior has evolved over billions of years, and maybe even uncover hidden resources or geological features.
Exactly.
Look, my mind is officially blown.
It's locked.
We've covered so much ground already.
Yeah.
And each instrument seems more groundbreaking than the last.
It's true.
This is seriously epic.
You were just getting started.
Oh, there's more.
There's one last instrument that deserves its own spotlight.
Okay.
One that's going to be shining a light on the moon's past and future in a way we've never seen before.
Okay, I'm on the edge of my seat. What is it?
It's called NGLR.
NGLR.
The Next Generation Lunar Retroreflector. We're literally going to be bouncing lasers off the moon with this one.
Yeah, the lasers in the moon.
Lasers in the moon.
This just keeps getting more and more sci-fi.
I know, but it's real science.
Right.
And it's going to give us some of the most precise measurements of the Earth-Moon distance we've ever had.
Okay, but why is measuring that distance so important?
Right.
I mean, it's not like the moon's going anywhere.
It's not about whether the moon's moving.
Okay.
It's about understanding how it moves.
Okay.
These laser measurements can reveal subtle changes in the moon's orbit.
Okay.
Its wobble, even tiny shifts in its shape over time.
Oh.
All of that tells us more about its internal structure, its gravitational field, and the forces that have shaped it over billions of years.
This is blowing my mind. We're talking about unlocking the secrets of the moon's past and future just by bouncing lasers off a mirror.
That's right.
This is why I love space exploration.
Yeah.
There's always something new to discover. Always another layer to peel back.
Absolutely.
And we've only just scratched the surface of what Blue Ghost has to offer.
Just the beginning.
So stay tuned.
Yeah.
Because in the next part of our deep dive,
Part 2,
we'll explore the potential discoveries and implications of this extraordinary mission in even more detail.
I can't wait.
Me neither.
It's going to be great. Welcome back to our deep dive into NASA's Blue Ghost mission.
Yeah, I'm still reeling from that laser reflector.
The NGLR.
Yeah, the NGLR. It's amazing how each of these instruments just seems to build on the others.
Right.
Like pieces of a puzzle.
Yeah.
Revealing a bigger picture.
That's a great way to put it.
Yeah.
Each instrument has its own specific job.
Right.
But together they weave this tapestry of knowledge about the moon.
Yeah. And like any good puzzle,
yeah,
there are bound to be surprises along the way.
Oh, absolutely.
Speaking of surprises, I'm really curious about Lister.
Yeah.
The instrument that's going to take the moon's temperature deep underground.
Deep underground. It's not just a simple thermometer.
Not at all. Lister is going to hammer a heat flow needle 10 feet into the lunar surface.
10 feet?
And as it goes down, it's constantly measuring the temperature at different depths.
Wow.
It's like taking a thermal cross-section of the moon's subsurface.
Okay, so we're not just getting one temperature reading.
No.
We're getting a whole profile.
A whole profile.
What can we learn from that?
Imagine you're baking a cake.
Oh.
The way the heat spreads through the batter tells you about its consistency, the ingredients, even if there are any hidden pockets of air.
Right.
Lister is doing something very similar for the moon.
Okay.
The way heat flows through its layers can tell us about its composition, how it formed, and even point to past volcanic activity.
So it's like geological detective using heat as its clues.
That's a great way to think about it.
That's fascinating. Now back to more practical problems.
Sure.
Lunar dust.
Right.
We talked about RAC.
Which is passively studying how dust sticks to things.
Right.
But EDS, the electric force field, sounds much more proactive.
It does.
How does that work?
Picture a grid of electrodes on a surface.
Okay.
When you apply a voltage to them, they create an electric field that repels dust particles.
Okay.
It's like an invisible shield constantly pushing away the dust.
But wouldn't an electric field interfere with other instruments or electronics?
It could, which is why EDS has been very carefully designed and tested.
Okay.
The electric field is strong enough to repel dust, but weak enough not to disrupt sensitive equipment nearby.
Okay.
It's a delicate balance, but it could be revolutionary for keeping lunar habitats and equipment dust-free in the future.
Okay, that makes sense.
Yeah.
It's like a high-tech version of those static cling sheets you use in the dryer.
That's a good analogy.
Now let's talk about the elephant in the room, or rather, the sun in the sky.
Yeah.
Space weather.
Right.
How is LEXI going to study this from the moon?
LEXI is like a sentinel watching the front lines of the battle between the sun and Earth's magnetic field.
Okay.
It's going to capture X-ray images of the interaction between the solar wind, which is a stream of charged particles from the sun, and Earth's magnetosphere, which acts as a shield.
So it's like watching a cosmic fireworks show in X-ray vision.
Exactly. And these fireworks can tell us a lot about the strength and dynamics of Earth's magnetic field, which is crucial for protecting us from harmful radiation. The data from LEXI will help us predict and prepare for solar storms that could disrupt our technology and even endanger astronauts.
So it's not just about pretty pictures. It's about protecting ourselves from those solar punches.
Very much so.
Now, back to the idea of lunar GPS. I'm still struggling to wrap my head around how LUGRE is going to use Earth-based GPS signals on the moon.
Yeah.
It just seems so counterintuitive.
Think of it like this.
Okay.
GPS signals are like ripples spreading out from a stone thrown into a pond. Those ripples reach the shore, but they get weaker the further they travel.
Yeah.
The same thing happens with GPS signals.
Okay.
Some do reach the moon, but they're faint.
Okay, so the signals are there, but incredibly weak.
Very weak.
How can LUGRE pick them up?
It all comes down to receiver sensitivity and some very clever engineering.
Okay.
LUGRE has been specially designed to detect those faint signals and filter out any interference. It also takes into account the vast distance the signals have traveled, correcting for delays and distortions caused by the moon's gravity and other factors.
So it's like tuning a radio to pick up a distant station, but with incredibly precise calculations to compensate for the cosmic distance.
Exactly.
And if LUGRE is successful, it could revolutionize lunar navigation.
It could.
Making it much easier and cheaper for future missions to find their way around the moon.
Absolutely.
That would be a huge step forward.
It would.
No more relying on complex and expensive lunar-specific navigation systems. Now shifting to another challenge of space exploration. Radiation.
Yeah.
We talked about RADPC, the radiation-tolerant computer.
Right.
Why is this technology so crucial, especially for future missions beyond the moon?
Think of radiation as a constant rain of tiny bullets invisibly bombarding everything in space.
Okay.
For humans, we have spacesuits and spacecraft for protection, but for electronics, it's a much bigger problem.
Because those tiny bullets can damage sensitive components and cause all sorts of malfunctions.
Exactly. A single high-energy particle can flip a bit in a computer's memory, corrupting data or causing a system crash.
Yeah.
And the further we go from Earth's protective magnetic field, the more intense that radiation rain becomes.
So RADPC is like a shield for our electronics, allowing them to operate reliably in those harsh conditions.
Exactly. It uses radiation-hardened materials and redundant systems, meaning it can take a hit and keep on going.
Wow.
It's also constantly monitoring itself for errors and correcting them on the fly.
It's like a self-healing computer built to survive the cosmic onslaught.
Precisely.
Yeah.
And the success of RADPC on Blue Ghost will pave the way for more robust and reliable spacecraft electronics essential for future missions to Mars and beyond.
It's amazing to think that something as seemingly simple as a computer could be the key to unlocking deeper space exploration.
It is pretty amazing.
Now, I'm really curious about those 3D images of the Blue Ghost landing.
Oh, yeah.
CLPS sounds like a real showstopper.
It's going to be quite a sight.
Yeah. But beyond the visual spectacle, CLPS is gathering crucial data about the interaction between the lander's exhaust plume and the lunar surface.
Right. It's not just about a cool image.
So it's not just about capturing a cool moment. It's about understanding the science behind it.
Exactly. When a rocket lands on the moon, its exhaust plume blasts down at supersonic speeds, scattering dust and rocks, and even changing the composition of the lunar soil.
So it's like a mini explosion that could affect future landings or even scientific experiments on the surface.
It could. CLPS is providing a 3D view of this interaction, allowing scientists to study the plume's effects in detail. This data will help us design landing pads, develop mitigation strategies, and ultimately ensure safer and more sustainable lunar exploration in the future.
It's like creating a blueprint for responsible lunar landings.
That's a good way to put it.
Now let's talk about LPV, the lunar vacuum cleaner.
The lunar vacuum cleaner.
Beyond the novelty of sending a vacuum to the moon.
Right.
What's the scientific value of collecting those regolith samples?
Lunar regolith is like a treasure trove of information about the moon's history.
Okay.
It contains clues about past impacts, volcanic activity, and even the composition of the solar wind.
So it's like a time capsule holding billions of years of lunar history.
Exactly.
Right.
And LPV isn't just sucking up anything it finds.
Right.
It's carefully separating the regoliths by size, giving us a more detailed picture of its composition and origins.
Okay, so it's like sifting for gold, but instead of nuggets, we're looking for tiny grains of lunar history.
That's a great analogy.
Now, to wrap up this part of our deep dive, let's talk about LMS, the instrument that's going to map the moon's interior without digging.
LMS?
It sounds like something straight out of a sci-fi movie.
I know, right?
But it's based on solid science.
Solid science.
LMS uses a technique called magnetotellurics,
right,
which measures natural electric and magnetic fields to probe the subsurface.
Exactly.
Think of it like taking an MRI of the moon, but instead of using radio waves, we're using these natural electromagnetic signals.
That's a good way to think about it.
So it's like listening to the moon's heartbeat, but instead of a stethoscope, we're using these sensitive electromagnetic sensors. What kind of information can we glean from these signals?
We can map the different layers of the moon's interior from its crust to its core.
Wow.
We can learn about the composition of these layers, how they've changed over time, and even detect any hidden pockets of water ice or other resources.
Okay, I have to admit, I'm still a bit baffled by how this actually works, but the potential discoveries are incredible.
It is pretty amazing technology.
It's like opening up a whole new chapter in our understanding of the moon.
It really is.
Welcome back to the Deep Dive.
Always good to be back.
We've journeyed deep beneath the moon's surface,
pretty far down,
battled cosmic dust bunnies, and even bounced lasers off a lunar mirror.
Sounds about right.
I have to say, this Blue Ghost mission is shaping up to be truly epic.
It is shaping up to be pretty incredible.
But as we wrap up our exploration of these amazing instruments, I think it's important to kind of zoom out and consider the bigger picture.
I agree.
Okay, I'm ready for the big picture.
Yeah.
What's the lasting impact of a mission like Blue Ghost? Is it just about the data we collect?
It's definitely about the data, but think of it like this.
Okay.
Blue Ghost is a pioneer venturing into new territory and paving the way for future explorers.
Okay.
It's testing technologies and gathering knowledge that will be essential for establishing a sustainable human presence on the moon.
So it's like those early explorers mapping uncharted lands. They weren't just looking for treasure.
Right.
They were creating a roadmap for future generations.
Exactly. The data from Blue Ghost will inform future missions, helping us understand the challenges and opportunities of lunar living.
Right.
We'll learn how to navigate with precision, protect ourselves from radiation and dust, and even utilize lunar resources.
It's like building a foundation for a lunar city.
Yeah.
Brick by brick, data point by data point.
I like it.
And I imagine there will be benefits back here on Earth, too.
Oh, absolutely.
All right.
Space exploration has a long history of driving innovation.
Right.
The technologies we develop for space often find applications in unexpected places.
Like how NASA research led to things like memory foam and scratch-resistant lenses.
Yeah, great examples.
Who knows what everyday inventions might come from Blue Ghost's innovations.
It's exciting to think about.
Right.
The radiation-hardened computer, the dust mitigation techniques.
Yeah.
These could have applications in fields like medicine transportation, even consumer electronics.
Yeah. So Blue Ghost's legacy extends far beyond the moon itself.
For sure.
It's about pushing the boundaries of human ingenuity and creating a ripple effect of innovation that benefits us all.
Well said.
But beyond the scientific and technological advancements, there's another aspect of Blue Ghost that's perhaps even more profound.
Okay.
Its power to inspire.
Ah, the human element.
Yeah.
Yeah.
It's hard to measure, but I think it's one of the most important outcomes of any space mission.
I agree.
Yeah.
Imagine a young student watching the Blue Ghost landing, seeing those first images from the lunar surface, and feeling that spark of curiosity ignite within them.
Yeah.
That spark could lead to a lifelong passion for science engineering or exploration.
It's like the Apollo missions.
Yeah, exactly.
They inspired a whole generation to reach for the stars.
Exactly. Blue Ghost might be a robotic mission,
right,
but its true legacy lies in its potential to inspire the next generation of dreamers and doers.
Yeah.
It's a testament to what we can achieve when we set our sights on something bigger than ourselves.
So to answer our original question, what can these game-changing instruments tell us? I think it goes beyond scientific facts and figures.
I think so, too.
It's about our place in the cosmos, our potential as a species, and the enduring power of human curiosity.
Beautifully put. We're not just sending instruments to the moon.
Right.
We're sending our hopes, our dreams, our yearning to explore the unknown.
And who knows what incredible discoveries await us out there.
That's the exciting part.
That's the beauty of it all.
Yeah.
The mystery, the anticipation,
yeah.
the sheer joy of pushing the boundaries of human knowledge.
It never gets old.
So to anyone listening, I encourage you follow the Blue Ghost vision.
Please do.
Read about the instruments, watch the landing, and let your imagination soar.
I second that.
And as we wrap up our deep dive today, I'll leave you with this final thought.
Okay, I'm listening.
Imagine yourself standing on the lunar surface, looking back at Earth, a tiny blue marble suspended in the vastness of space. What mysteries would you want to unravel? What questions would you ask? The journey of exploration is just beginning, and the answers are out there waiting to be discovered.
Very well said.
Until next time, keep looking up and keep exploring.